What I want to talk to you about today is how Liferay uses Amazon in their daily workloads, how a lot of our clients use Amazon in their daily workloads, and how you might be able to. I know that in Europe, you guys have some regulatory hurdles that we don't necessarily have in the US as far as storage of data, how you store it, and where you store it. In 2014, Amazon did launch the Frankfurt region, so you can store your data in Germany, in Frankfurt, or also in Ireland. So those are options available for you. So you get around the non-starter of, I can't use it, my data is not in the EU. Your data is in the EU. Your data can be held guaranteed all in Germany or all in Ireland, which is a very nice plus. So how does Liferay use Amazon, and why does Liferay use Amazon, and why do I personally think it's a really great way to host your Liferay environment if you want to manage it yourself, but have very little time to actually set up servers, run cables, and crimp Cat5 connections, right? Nobody wants to do that anymore. It's a terrible experience because your hands, after a while, get really raw right there when you're trying to work the little cables out. So we use it for all managed services, which I'll explain in a second. A lot of our internal testing goes into AWS, and a lot of our proof of concepts for things like sales go into AWS, or things that we want to work on, but we don't necessarily have the time to spin up boxes internally at Liferay. We have an AWS account that we can go ahead and use to spin up a couple boxes here and there, and it's very convenient. Managed services is a new thing that Liferay does. We haven't always done it. Basically, what that is GS, Global Services Consulting, will take your site and manage everything for you. We'll spin up a host, we'll help you figure out your designs, we'll figure out your user interface, your user experience. We'll even help you build out pages and things like that. This is for clients that want to use Liferay but have no IT of their own, or simply don't want to deal with it. It's a Windows IT team, they don't want to deal with Linux, they don't know it, they don't want to pay a host, they'd just rather come to us for a one-stop shop. This is something that we use Amazon for because it saves us a lot of time. Why does it save us time? Because it's so lightweight. For managing all of our stuff, we only have 2 people with AWS access, right? 2 people for our entire IT department is unheard of. We're talking 60 plus servers that are being managed in real time by 2 people. It's awesome, right? And the last thing you want your developers to be doing is wasting their time managing servers. That's not what they're there for. With this, we don't have to really worry about it that much. We can fire off builds, do provisioning, do deploys, do all of our hotfixes with a simple push of a button, normally managed through Jenkins for continuous integration, but we don't even have to. A lot of us know Chef now, and we can do automated deployments that way through DevOps, which is really cool. And I did actually, last year or 2 years ago, a full talk about DevOps and Liferay and Amazon, how to do it. And that's on YouTube as well. If you want to go, you can see my DevCon talk from 2 years ago that lightly brushes on this stuff, as well as more DevOps-y stuff for log monitoring and performance. So how do we only use 2 people, right? Because that's pretty hard to do when you're running this large of a stack. And basically, we can use CloudFormation. If you don't know what CloudFormation is, it's basically a big JSON file that defines what our network should look like. It's like software-defined networking, but not really. It's really cool because you can have load balancers and you can have full subnets set up and everything like that, all in one file. And we can take that one file and distribute it across all of our clients. So once we set up an architecture that we really like, we can distribute that across everybody very easily and very reproducibly. And when we find a problem, something that somebody needs, we can give that back to everybody else very quickly, again, because all this data that says we need 2 servers, a load balancer, we need a database, we need Nginx as a web server, that's all just defined in a little text document. So when it's time to give that goodness to another client, we just put the file up, hit the load button, and it builds the whole network up for us. So all we have to be concerned with is development. We're writing portlets, we're writing OSGI modules, we're doing other stuff and not wasting our time worrying about how that stuff gets to the public, because we don't want to waste our time doing that. So how do we keep things running? Autoscaling groups are amazing. We had a client that wrote a piece of code in Velocity because in managed services, they have the ability as admins to build whatever they want and throw it in. It's their environment, they can build it. But if that means they write a piece of code that accidentally fills the file system up, which happened once, Amazon will take care of it for us. It just shuts the node down, brings another node up, and as soon as that node's available, it reintroduces it back into the public internet. There's no downtime as far as they're concerned, and then it fires off a bevy of emails and text messages to us saying, holy crap, something's going on, and you need to stop it, right? It was really great. For performance monitoring, we use Dynatrace, and we love Dynatrace. For production, I really can't recommend it more. There are other options available, but we personally enjoy that one. We have a nice partnership with them, which doesn't help us monetarily at all. They just give us a nice discount for the servers that we're running. So it's really nice. I highly recommend it. And because we're talking about DXP, Elasticsearch boxes we include in our CloudFormation stack. And that gives us nice redundancy, right? We can have a cluster of Elasticsearch boxes and a cluster of Liferay boxes, and they always just keep running, which is really great. So some of this talk is going to be a little technical. I'm going to show you a little bit of code. I'm going to talk about Amazon-specific things like C4 2x large app servers. The reason I do that isn't so you can remember it, because nobody's ever going to remember that sitting in a 26-minute talk or however long this thing is supposed to be. I do it because we distribute these slides at the end, and I want you guys to be able to copy-paste, right? So in the end, you say, what server should I run? Your manager comes to you and says, oh, you saw this talk, and now you want to use Amazon. What server should we buy? I don't want to pay for something that's way too big, but I also don't want to get something that's too little, and our whole site's going to be unresponsive. So the stuff that I describe here is what we use on a daily basis for Liferay.com, all of our internal Liferay sites, and a bunch of our clients. So Dev is embedded Elasticsearch because I personally don't like paying for extra servers that I don't have to. If it's just Dev, why am I going to spin up an external Elasticsearch box? It doesn't make any sense. C4 2x large app servers, which are basically like 16 gigs of RAM and 12 core machines or something like that, plenty. Tomcat 8 and Nginx. The Nginx discussion was quite the fight internally. Half of us wanted to use Apache, half of us wanted to use something new and cool. The Nginx team won out because they're the ones that wanted to manage it. So there you go. You guys have fun with that. And for RDS, we use actually T2 smalls. It turns out Liferay is actually not that heavy on your databases. It's heavy on your app server side, but for the database itself, you can run T2 smalls and it runs great, and that's cheap. A T2 small costs me, I don't know, $16 to $20 a month to run for a database that's fully managed by Amazon. That's inexpensive, guys. Like, I don't have to worry about it at all. So production's a little different. For production, we're actually running C4 2x larges, which is fine, but we're also running 2-node at least clusters. We always run at least 2 nodes in production. It's a general rule for safety. Even if clients don't want it, we'll do it anyway, because something can go wrong. And if something goes wrong, we don't want production to go away, right? You always want your production to be up. 2 nodes minimum. And what we love to do is use S3 ping. S3 ping is a technical term, basically. When the Liferay cluster comes up, all the nodes that come up in the cluster need to be able to advertise themselves and say, hey, I'm available, I'm in the cluster, make sure that when somebody adds something, I know about it as well. Well, there's a couple ways to do that in Liferay. There's like TCP ping, which basically you have to pre-list all your nodes so everybody knows who everybody is, or there's multicast. Unfortunately, multicast is the best way to do it for performance. That's, if you can do multicast, you should. AWS doesn't support multicast. It's layer 2 networking, you cannot do it. So we have to do something else. What's really cool about S3 ping though is basically in Amazon there's something called S3 and it's file storage. So Liferay will create a little file in their file storage section and it'll just list out every node that's available, and it does a little health check. So every 30 seconds it pings everybody, hey, are you still alive? Yes, you're still alive, great, you can stay in the file. No, you went away for some reason, take you out of the file, now you're not in the cluster. What's really cool is there's some ambiguity when you're a developer or a sysadmin working with Liferay as to what nodes are actively in the cluster at that time. It's a little hard to tell from like the UI. What's cool about this is I can just look at the file and I see every single node. So if I'm supposed to have 16 nodes in my cluster, I should see 16 entries. If I only see 15, it's a simple matter of looking at which machine is missing to know something's not in the cluster, something's wrong, which is great. I've also built little health check apps based on that to just count the lines in that file to make sure my cluster is in good condition. Elasticsearch, more technical details. It's a C4 2x large with a 2-node cluster because Elasticsearch can be a little heavy sometimes. For document library, we use S3 in general. AWS has something called EFS, which is just an NFS v4 service that's available. So when that came out, I really wanted to use it. I thought, oh, this is going to be so cool, you guys. We don't have to use any weird S3 connectors. We can just use it like a regular old file system, and everything's going to be really great. It's not. It's not really great. I did a bunch of testing, and S3 is literally 10 times cheaper. S3 costs 3 cents per gigabyte per month of storage. 3 cents per gigabyte. That is so cheap. NFS is 30 cents per gigabyte per month. So it's literally 10 times more expensive. And it turns out it's slower. So when I tried to do my migration from S3 to EFS, like if I try to go from, say, dev to QA to production when I'm building up my environments, when I clone S3 across those environments, for a couple gigs, it takes seconds. When I was doing it with EFS, it was taking minutes. And that scares me, right? I want my site to be very responsive. So I'm definitely recommending not to use EFS. You want to use S3. And there's actually some other benefits. Not only is it faster to talk to Liferay, but it gives you a public-facing site. Who here hosts large-ish files, say 50 megs and up in Liferay Document Library, right? So when people go to download that, it does some interesting things. It jumps into Nginx, jumps into Tomcat, opens up a connection, streams the file, right, back to the user, and then closes all the connections. Let's say that takes 40 seconds. That means that that thread in Tomcat, of which you only have a limited number, maybe 400, maybe 300, is being used that entire time to stream that file. And it's kind of a dumb operation to waste a whole thread in Tomcat on. So with S3, you can actually create public URLs, which is really great. In the document library, you click the download button, and it goes, hey, is this a public file? Like no permissions attached to it? Yes? Let's just get it right from S3, right? You totally bypass all those steps. It jumps to the public internet in S3 and just grabs it and brings it down. Liferay doesn't even know it was downloaded other than the fact that the link was clicked. Very fast, very cheap, very available and ready for you. Because if you have somebody in China that's trying to download something hosted in Frankfurt, the old way, they have to go to Tomcat in Frankfurt, get the file, and send it back to China. With S3, they'll replicate it across regions if you want to. So you can actually have somebody from China pull the data from China if you want to turn that on. You don't have to, but you can. And automated backups and long-term retention. Why do I call out long-term retention specifically? We had a problem at Liferay. One day we woke up and we noticed that our knowledge base was missing. Well, the knowledge base was there. It was on a public site. You could see the text, but all the images were gone and all the downloads were gone. It turns out that somebody had made an oopsie and they thought that they were in dev and they were in production and they dumped all of our files off of S3. Every file that Liferay holds was gone, right? Which is horrifying. So how did we fix it? I had turned on, thankfully, branching and versioning in S3. And when I turned on branching and versioning in S3, which is just a feature, kind of like Git or whatever, for file storage, I removed Liferay's permissions to remove revisions. What's that mean? That means that Liferay can go in and create files, edit files, delete files. When it does, it doesn't actually delete the files. It enters a marker that says this file is deleted, but the file actually stays. And then I removed the permission so Liferay couldn't delete the markers, right? And this is something that you can do in S3 very easily. It took me like 3 clicks to set it up. So Liferay can go in and work on itself all day long. All things look good. But if something goes wrong, I can just go in and undelete all the markers and all the files came right back, right? So that saved us weeks of headache because we literally had no other backups. It was just, that was what we had. For that alone, I love using S3. I love it. For outside communication, how do we do it? Because a lot of people send bulk emails. Who here sends more than 100 emails a month from their Liferay instance? Anybody? Okay, great. So do you guys use SMTP for that? Yeah? No. Okay, so some yes, some no. SMTP is slow. It's horrible. So I used to work for a Hewlett-Packard Enterprise, well, consult for Hewlett-Packard Enterprise. And they sent more like 30,000 emails a month. Okay, we burned through emails there because we had to notify partners of things. We had to say, hey, new products are available, new things are going on. It was really great. But we would saturate their SMTP servers, saturate them. It would take us 2 weeks to finish off 30,000 emails, like of just churning through them, trying its best. Their SMTP servers were very slow. For Amazon, there's 2 ways you can do it. You can use SMTP if you want to. It's still slow, but it's very easy to set up. It's super convenient. Also, you can use something called SNS, which is a simple notification service. And you can actually send emails through a web service call. And the web service calls are great because you can just replace, using OSGI, you can replace the mail engine that tries to connect SMTP, and you just instead inject your web service calls. And we can burn through 30,000 emails on that now in about 5 seconds, roughly. And it's async, so it'll notify us if anything doesn't go. That goes onto our message bus. And then later on, it will go into a workflow for us to say, hey, these emails failed. Check the email address, make sure they're valid, blah, 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 right? So very, very handy there. We also use it to send text messages. So for certain notifications, I like to have Liferay text to my phone because I don't want to wait for an email to come through. I might not notice it. And that's very nice. And it's cheap. It's a penny a message or something like that for text messages. It's not bad at all. So nothing's perfect. There's no such thing as heaven on earth, and Amazon is definitely not that. So what problems do we see on a daily basis? It's so dynamic. It's so dynamic, it's beautiful to watch, but it's kind of a pain to manage sometimes. What you can see is if a machine goes away and then comes back due to an auto-scaling action, like I mentioned earlier with the hard drive filling up, the IP addresses will change for that machine, and you have no way to predict what that IP address is going to be. That's a problem for something like staging, right? If you're going to use staging in Liferay, you want to know what the IP is because you have to whitelist that IP to be able to publish remotely, assuming you're using remote publishing, right? And if your IPs are constantly changing, you never know what those IPs are. That was a real struggle for us at first. We had to figure out how to get around it. And I've actually got a really awesome way to do it, and I've included the code here for you guys so you can just copy and paste it if you want to, assuming you use it. Also, how do you manage logs? So, I mean, Nathan is in here somewhere. He's working on a project, and we had an issue where we were dropping machines every day almost, and you lose those logs. They're gone, straight up. So sometimes you want those back to see what's going on. How do you retain those? And how does licensing work? Because as you guys know with Liferay, back in 6.2 or before, you got a cool little XML file, and that was tied to the MAC address, IP address, which once again changes every time your machines autoscale. How do you deal with that? The answer is LCS, right? Our licensing service, which actually does hourly licensing now, has for a couple years. So you can spin up and down machines on a per hour basis as long as your license supports it, and only pay for what you use. So you don't have to prepay for a whole year. You can pay for minutes at a time, which is really cool. So addressing the first question, how do we manage logs? We actually have been using the AWS Elasticsearch service. Unfortunately, you can't use this to back your Liferay searches. The reasoning is Liferay uses binary TCP connections to connect to Elasticsearch, not HTTP, and Amazon only supports HTTP for Elasticsearch, so unfortunately, you can't double duty this. It would be great if we could, but we just can't. What we can do, though, is use something called Kibana to parse all of our logs. So we take all of our logs using Logstash as soon as a machine starts. So imagine a life cycle. A machine comes up for the first time. It's replacing another machine that's dying. And Liferay sets itself up. Liferay starts. And when Liferay starts, it also starts an agent on the side. And the agent just monitors all of our logs. XML logs, JSON logs, as well as regular text logs. It will parse those and upload them into Amazon's Elasticsearch service. That's super duper cool because now all of our logs are being stored in Amazon in the cloud. So that machine can drop away at any point and the logs are persisted, which is really great. By default, Amazon gives us access to Kibana. Kibana is really cool for viewing logs. And we use something called Grok, which I know that's like, what? But it's just a plugin that you have to use. You get the code in here later, that tags all of our environments. So when I search for logs, I can say, I need to see all logs between these two times where this user was accessing my site because I take the user ID and I store that in the logs as well through cookies. I have Nginx store that as a cookie, and then I have that output into my logs. And then I say, what environment am I on? Production, dev, QA. What machine am I on in that environment? All in the logs, and I can parse it. So I can say, show me all logs from this machine that died 2 days ago, where this user was using it because they told me something happened and I want to see what happened. And I can follow the logs from Nginx all the way to Liferay and just create a little path, which is really great, a little breadcrumb, which I like a lot. I'm not going to spend too long talking about the code, but I wanted to show you guys that it's there. Basically, we take and monitor the Liferay log files in JSON. Also, later on, if you want, I can give you this. Basically, you can add a new log4j connector that will output all of Liferay's logs in a JSON format for you. So you don't have to do any parsing for that. It's really cool. And then we always start at the beginning because I don't want to lose anything. And as you can see, I'm tagging with the environment name. The real quick of how do I know what that environment name is, Amazon does a really cool thing where at the web address of 192.168.254.255.254, you can get that, and it gives you all your instance information. What size your machine is, how long it's been up, what your tags are, all that stuff. So we tag all of our machines in Amazon, and then I can access that information at the OS level and inject it into my logs, which is really cool. And then as you can see, my output is Amazon Elasticsearch output with the host that Amazon told me to use when I created it. And I was smart enough to sanitize my ID and key so you guys can't steal my logs. And that's it. It's those 3 lines push all my logs from all my machines up into Amazon. It's seriously, seriously easy. And then here's the variables. So like I said, I can grab my instance information and my region all from this information. So this tells me the name of my environment, what region I'm in, and my instance IDs and everything else. So this will tell me you're in production. You're on node 2 of the cluster. It's perfect. So the other question is, why does the machine autoscale, right? When I told you guys we had that outage due to size, we needed to figure out why. Luckily, it was all in the logs. When I fired up Kibana, I was able to look at it, and I just saw immediately disk space exception right there. Like you just looked up that machine, disk space exception, done. It was gone. Perfect. So Kibana works, CloudWatch works. CloudWatch is like an Amazon supplied monitoring system, but it really is only instance level. So it tells you like CPU usage, memory usage, but it doesn't give you the nitty gritty details of your Liferay installation. So there's value there, but not as valuable. Dynatrace really is the meat and potatoes of our monitoring. It's great for watching the JVM and memory usage and CPU usage, thread usage, everything. Remote publishing. I promised that I would tell you about it, so let me tell you about it. What we did was we had publishing set up, and when you would publish, it would go to the public internet and then publish back down. There's a couple problems with that. Problem number 1 is that's expensive, because you're now sending data outside of Amazon to the public internet, which you get charged for, and then re-downloading your same data. If you're staging a lot of documents, that can get expensive real quick, especially depending on how many files you want to stage. Also, it's a little slow because you're going out to the public and then back in to your own cluster, which makes no sense at all when you think about it. But it was just one of those things, this is how you do it. Okay, we'll do it. But when we sat down as a team and thought, that's how you do it, but does that make sense? The answer was no, it doesn't really make sense. So I built a cool little script that uses Route 53. Route 53 is a DNS system handled by Amazon. When the machines all boot in an environment, so dev comes up, it's 1 node. That's easy. QA comes up, it's 2 nodes. Production comes up, it's 4 nodes, right? So what node do you publish to? You can technically choose any of them, but in Liferay, you have to whitelist those IPs. Otherwise, it won't accept. So what I did was I set up staging-dev.liferay.com for us internally, or insert your client's name there, right? And I set it up so when machines boot up, they automatically run a script that grabs their own internal IP and their environment, and the last one to boot will upload its IP address as a DNS entry. So now when I do staging pushes, I can just push internally, which is great, because now when I do a remote publish, I'm publishing internally. All the data stays inside the cluster. I don't go to the public, and the data transfer is totally free. And I think we saw something like a 20 to 30% increase in speed when I did this. So it was really quite nice. And And then as the machines drop off, the next ones will take over that IP address, and it's always live. Your biggest concern is if that machine auto-scales while the publish is occurring, but in theory, that's all transactional, so it should be okay. So that's a quick description of what I've got in the next couple slides. Once again, I'm gonna give you the JSON stuff. I don't want you to look at it now. You're gonna glaze over, and I'm gonna ruin the next talk because you're gonna fall asleep. So just take the deck, copy and paste it later, and you'll be set. It's basically just a quick insert. Here's the IP that the DNS that I want you to go to, and here is a placeholder value. And then I have a little script that replaces that placeholder value with my local IPv4 address. See, there's my little placeholder. And here's my grep statements and stuff to replace it all. In the end, you end up with a cool little JSON file that gets parsed. Right? So the final line there, you're good to go. Copy and paste all that, and you're set. Licensing is super easy with LCS 402. Anything before 402, upgrade. So that's the biggest thing I'm going to give you today. Why? Because LCS is resilient, but it's not super duper resilient in that if you go into a grace period for a reason. The grace period is you have a license, it's valid, but for some reason Liferay can't verify that that is valid. So it sends you into a 7-day grace period. And there's nothing like logging into your production environment after doing nothing at all to change your machine for 3 weeks and see that you're in day 3 of day 7 for a grace period and your machines are going to shut off in a couple days, right? That's also horrifying. So in 402, we fixed it. Basically, we do a heartbeat ping and we'll keep checking to see if you can come out of grace period if you're in it. That has saved us a lot of times. So upgrade for sure. You definitely want to, even if you're not using Amazon. If you're using LCS at all, you want the latest version of the client. It's way better. And if you don't have access to the internet for some reason, which some don't, right? Banks, financial institutions, healthcare institutions, sometimes their app servers don't have access to the internet. In that case, we'll give you an XML key, which works. We use CDNs, which if you don't know what a CDN is, you should really look them up. They're really great. But we use them to offload all of our data processing for images and large files, which is awesome. And CloudFront is good for that, which you can use even if you don't use Amazon. So if you don't host on Amazon, you can still use CloudFront or Akamai or pick a CDN. Either way, you should definitely be using some sort of CDN. That's another take home. Use the CDN if you're not. This is what it looks like for us. We set up 2 types, one for document library and one for everything else. That way we can manage them more granularly. It works really well. For building, we use Jenkins and Packer. Jenkins basically builds it up, and Packer puts together an AMI for us, uploads everything. It's very simple. Fires off from a Git tag, and you're done. It creates all of our environments for us, nothing to worry about there, and also launches our environments in a way that doesn't give us downtime, which is great. We use CloudFormation to do a bunch of our stuff. Things we don't manage from CloudFormation are Route 53, ELBs, and VPCs. Anybody that knows Amazon knows you don't want to. It's a bad idea. If your ELB gets deleted for some reason, when it recreates, it's going to create absolute hell for you. So those are the things you don't want to manage, which I explained there. And that is it. So I know it was quick. There's a lot of stuff to cover, but I made it by 11 seconds. So I'm feeling really proud of myself right now. But
Thanks,
that
Brett.
said, I love this. Find me afterwards if you want to clarify anything, or if you want to see any of this working in real life, and I'll sit down and show you everything from our Amazon console if you want to. Okay?
Yeah, we have 10 minutes for questions. So.
Oh, great.
So if anyone has questions.
You mentioned the message bus that you're using somewhere internally for those emails.
Yes.
What kind of message bus are you using, and is it the internal Liferay message bus or something? Okay.
It is the internal Liferay message bus. We built out, for this particular client, we built out a custom endpoint.
So it's a custom. It's not the message bus you do something. It's
it is the regular message bus, but we needed to be able to accept things onto our queue from outside Liferay. So a third-party system, in this case, Amazon SNS. So we just built a cool RESTful endpoint that just sticks things onto Liferay's message bus. Because when you're sending out 30,000 emails, what I don't want is for it to shove 28,000 invalid emails or something like that into our system with no way to process them well. So we like to queue them up on a message bus so they can get handled when Liferay's ready to handle them. But it is regular old message bus from Liferay with a regular old endpoint that just pushes things onto our message bus. That's all.
Okay, thank you.
We have another question there, on the other side.
Hey.
Hi.
Great presentation. I really enjoyed.
Thank you.
I was curious, how do you handle the scale in? Because like the scale out, you create like new instances, but do you also handle the scale in, reducing instances?
We do.
And how does it
all the way down to 2. We always stop at 2.
stop it?
Yeah. So your question is, how do you handle auto scaling? In Amazon, there's a couple ways to fire that off. We usually use CPU usage. So if the CPU usage on the cluster averages over 80% for more than 7 minutes, then we'll scale up 2 machines at a time. And when we drop below 40%, we'll scale down 1 machine at a time. We like to scale up quickly and down slowly, because I don't want to go, oh, everything's running great now, we'll drop everything back down. But if you do that too quickly, you can just hose yourself all over again. You end up flapping. So we usually use CPU. We've experimented with creating our own metrics, because in Amazon you can do that, and using things like the JVM heap, for example, to determine whether or not we should scale. But with 1 minute of granularity for that, which is what Amazon does by default, it just wasn't quite granular enough for us, so we went back to CPU usage. And it's pretty good. It's pretty good.
Hi. First of all, thank you for an inspiring presentation. I have a question regarding those S3 public URLs. Could you please describe this more? Is it just a feature that you switch on in the infrastructure, or is it an attribute of the connector, or you need to configure somehow Liferay to do this?
It's an attribute of the S3 connector that Liferay gives you. It's something that you have to turn on, and usually there's a little bit of code just to intercept the URLs. But I think it was like 15 lines of code in an OSGI module. It wasn't a big deal. I've got an example that I can kick out. If you want to email me, I can get it for you. But what's really nice about it is you can actually set it up so if a document is public, then it creates a permanent URL. So whenever somebody goes to download that document, it just rips it right from S3. Awesome, great. What if you have a permissioned document that you want people to be able to download, but it's also huge, like a 2 gigabyte ISO or something like that of a testing environment? You can time bomb them. So you can actually say, I'll create a URL. That URL is valid for 15 minutes. And only you get it. You can share it with whoever you want, but if they don't get it within 15 minutes, it's done, right? So that's one of the things that I really like about it. And that's all built into the API. You can just choose what you want to do.
Nice, thanks.
Any more questions?
Hi, Tony from Liferay. In matter of scaling down, if a user, how do you scale down or kill a machine if already there is a session and in this case, the user is going to be disconnected? And what about if we are going to implement it is financial sector?
So you
for
can
scaling down. Yeah.
You can check an option on your scale down to enable connection draining. So basically, as the machines want to scale down, they'll look to see if there are any active sessions. If there are, it will remove itself from session creation, but will allow the sessions to continue until they stop. So you've got maybe a 15-minute delay until people stop using and their sessions invalidate, and then the machine will let itself die. But it won't rip a user out from underneath it.
During this time, the load balancer prevent if a machine is going to be killed, prevent additional user to create session. So
Yes.
this is additional customization at Liferay level?
That's default
or
Amazon.
Default Amazon.
That's default AWS. No new connections. Any existing connections must drain out before the machine gets shut off.
Okay, guys, last question, please.
Yeah. Hello. You mentioned that your Elasticsearch setup has 2 nodes. In your experience, how reliable is having this 2-node cluster of Elasticsearch?
I've actually never had an Elasticsearch node go down, ever.
Yeah.
So for me, it's safety more than it is reality. I've never had one fail. I'm sure that maybe, have you ever seen an Elasticsearch node go down in production?
Not by the node, but maybe the underlying machine.
The underlying machine, possibly, yeah, but I've never seen Elasticsearch take a whole node out.
Because there is a recommendation from Liferay.
Well, yeah, in production, we recommend you cluster all the things.
Put 3 of them, at least.
Yeah, you'd want an odd number so you don't split brain. But for 2, I've never seen it happen. All right.
Thank you.
Thank you.
Thank you, Brett.